Hello, this is Peter from Educomondo, and a warm welcome to our STEAM project number 17, in which we will make a small fan to refresh us when it's too hot in the classroom. These lessons are for the absolute beginning STEAM teacher. No prior knowledge of programming or electronics is required. We call this level the Explorer level. Till now we had projects involving LEDs and different kind of displays. The goal of today is to control the speed and the direction of a DC electric motor. DC stands for direct current. We will introduce to our class the motor driver or controller integrated circuit called L293D. We will add an external power supply to our project, and last but not least, we will encourage teamwork in the classroom so that everyone is successful. Let us take a closer look at one of the oldest and most popular direct current brushed electric motors. This is a simple motor that only requires two wires. Connecting these two wires to a battery will make the motor spin at full speed. Switching the polarity will make the motor run the other way around. It is a very versatile motor, most often used to drive wheels of robots or to create a small fan, such in our project. We control this type of motor with an integrated circuit called the L293D. In most of the kits, this controller is included. It looks quite the same as the serial shift register that we used before, so make sure your students do not mix them up. In robotics projects, you will often find a more powerful version of this integrated circuit, namely the L298N. And most likely it will already be installed on a print with easily accessible pins and with a cooling fin or heatsink, because the IC can get really hot while controlling intensively two motors at the same time. Let's distribute the few components that we need for this project. The microcontroller and the breadboard, the integrated circuit L293D, the DC motor, the external power supply, an external power source like a 9-volt battery, preformed wires, a couple of jumper cables, and of course the plastic fan. Let's first get acquainted with the 16 pins of the motor driver or controller. To orientate the IC, we look for the small indent on the cover. Pin 1 starts at the left top and we go counterclockwise to pin 2, pin 3, pin 4, all the way around to pin 15 and pin 16. Pin 1 is called ENT1 and it controls the speed of the DC motor. It has to be connected to one of the pulse width modulation pins, you know, the ones with a tilde. Pin 2 and pin 7 are called IN1 and IN2. These pins control the direction of the motor, and they will take their input from a digital pin set to high or low using the digital write command. Pin 3 and pin 6 will take the black and red wire connected to the motor. Pin 3 is out 1 and will take the red wire. Pin 6 is out 2 and it will take the black wire. Pins 4 and 5 are 0 volt or ground pins, and pin 8 will be connected to the 5 volt rail of the breadboard. The other side of the IC is exactly the same to control a second motor. The left pins control one motor, the right pins can control another motor. To help your students, leave the pinout diagram projected on your screen or on a whiteboard. You can also make these small reference cards. Your students will be ever so grateful. Okay, let's tackle this project. The first component we add is the external power supply. This clicks onto the project board and will add power to the outer plus and minus rails. Because the brushed DC motor requires quite some power, the microcontroller itself is no longer capable to provision that power. Even worse, connecting the motor might destroy the microcontroller. We should also make a common ground between the Arduino and the external power supply on the breadboard. That way, all components will be nicely connected. The next step is to mount the motor driver. We ensure that we know where the notch is, because that is our point of reference to define the rest of the pins. In our case, the notch points to the left side, which means that pin 1 is the first pin to the left, counterclockwise. The pins of this chip are very fragile and bend extremely easily, so ensure that your students mount this component carefully. Let me show the pinout diagram on screen to make it easier to follow. The first step is to use the preformed wires to connect the ground pin number 4 and the volt pin number 8. Next we connect pin 1 to digital pin 3 with a tilde symbol indicating that it is a PWM enabled pin. Pin 2 and 7 are the direction pins and we connect them to the digital pins 4 and 5. Chip pin 3 takes the red connection of the DC motor and pin 6 takes the black wire. Now we can connect our battery to the power supply and we make sure that the small switch is pushed to the on position. An LED should indicate that there is power. That's it for building the project. Let us open an Arduino sketch. As always, at the top we write our lesson 17 and we also declare our variables. In today's project, we have 3 pins that we need to define. The pin that controls the speed, which we call conveniently speed pin, and it is the PWM pin number 3. The 2 pins that will control the direction of the motor we call dir1 for direction 1 pin and dir2 pin, and we link those to Arduino pins number 4 and 5. So INT dir1 pin equals 4 and the second one is 5. Because we will change the speed of the motor, we also create a variable motor speed. And as we don't know the value yet, we don't need to add anything. But we do know that this will be a value between 0 and 255. Now we can go to the void setup, where we have to set all the pins as output because we will be writing to them. So we use our pin mode, and for the 3 pins that we have defined, all 3 we put as an output. And in case we want to check something on the serial monitor, we can also initiate the serial monitor with baud rate 9600 using the command serial.begin. Next we go to the void loop, and in the loop function we want to gradually increase the speed of the fan. We can do that with a simple for loop. For in between rounded brackets motor speed equals 120, and for as long as that motor speed has not reached the value of 255, we increase the motor speed with a value of 5. And what do? We do a digital write of the first direction pin, and we set it to low, and we do the same for our second direction pin, but this time we set it to high. We also do an analog write to our speed pin. And what do we write to our speed pin? Well, we send the motor speed variable to that pin. Here we can also introduce a short delay of 500 milliseconds. And because we want to check what's happening on our serial monitor, we also use the serial.print command, where we first put a sentence, PWM value, and then we print the variable motor speed. And we close everything with the curly brackets. By the way, the reason why we start at a WM value of 120 and not by 0 is that this type of DC motor will only kickstart itself when the value is around 100. Let your students upload the program, and if all is well, the classroom will be cooled in no time. On the serial monitor, you will see the PWM value going up with increments of 5. You can ask your students to set the direction pin 2 to low and the direction pin 1 to high, just to check the change of the direction of the motor. If for some of your students it doesn't work, tell them not to panic, but let them do some logical fault finding as we did in the past. First, let them check whether there have been any error messages on the Arduino IDE. Were there any loose wires or connections on the breadboard? Have none of the legs of the chip been bent or broken? Is the external power supply switched on and set to 5 volts? And is the battery sufficiently charged? Let's revisit the goals of today's lesson. First of all, your class has the skills to control the speed and the direction of a DC electric motor. They also know about the motor driver called L293D, and they understand how to link this to a microcontroller. They now also know how to include an external power supply to the breadboard for power-hungry devices. And last but not least, your students work together as a team. We had some great fun with building this fan, so here are some ideas for an assignment. Ask your students to design and fold a colorful fan. They can also build a colorful kite, and you can ask your class to fly them when there is sufficient wind. And on a more scientific note, you can ask them to think about what is wind, and also let them check how the speed of wind is expressed. Now, we all know that the wind can be a refreshing breeze, but it can also be a merciless tornado. So ask your students what are the different types that they know of this weather phenomena. For instance, typhoons or the French Mistral. These are just some suggestions. As a teacher, you know your class best, and you are the ideal person to come up with your own assignments. This concludes our project number 17, the cooling fan. Controlling motors is an important skill for robotics, and in our next lesson we will work with another kind of motor called the servo motor. I'm really looking forward to welcome you again in lesson number 18 called the car speed dial. Take care and bye bye for now.